Let's look at a couple of project structures that I recommend. Again, this isn't the only project structure that will work, but if you're going to define your own project structures, at least make sure that some of the design philosophies that we're talking about can be applied. It's going to be so important. Remember, consistency in everything you do is really where you win or lose the game. Now, I recommend that every team, if you could do it at a company level, it's even better. But at least every team have what I call that Git project. And when we talk about project, we're talking about a single repo of code as well. So if you're using Git, I'd want a repo in Git, and that Git would have its own repo. And the idea of the Git package, or I'm sorry, the Git project, is that is your standard library. That is your team's or your company's standard library. Most of these packages, if not all of them, are foundational packages. We're not talking packages that don't necessarily have business logic in it. They could, depending on what you're building, but a lot of these are foundational. So your web support, database support, logging, config, these types of foundational things that all applications that you're building probably should be using. Think of it as your own standard library. I love this idea. And I think you could keep it in one repo. Some companies, some developers like to have a separate repo for these foundational packages. I just think it adds a lot of extra work and maintenance. So we want that Git package, or project, sorry. Then you have what's called the application project. And again, this is where you can have many different types of structures. I think less is more. And I go after that, less is more. And I've come up with these 4 folders that we're going to use for projects. And I think it works for all types of projects. So this is what we do at Arden. This is what I teach day in and day out, this project structure. And it's a good place to at least start if you're not sure how to structure your apps. Now, you can see there's 4 folders here. There's the CMD or command folder. That's where the binaries are going to be. So you might have a project that's building multiple binaries, multiple services, maybe because you're doing microservices, CLI tooling, Lambda functions, background, cron jobs. Whatever it is, you don't need one project structure per binary. Again, that would be way too much management work. You could have easily 4, 5, maybe up to 8 developers in the same project if you organize things properly. I think one thing, what's nice about packaging is it does lend itself for that. So the idea is that multiple binaries will have their own folder under command. I'm going to show you that in a second. Now, internal is a really special folder name because any packages inside of internal will truly be just internal to this project. And the compiler is going to come in and protect that from you. So if you've got 2 separate projects and one's trying to import an internal package from the other, compiler will say no. I really do love that internal name. And we're going to put business logic inside of internal. So if you've got packages that are providing business level logic, service level logic, we're going to put them inside of internal. The whole idea right now is we know what packages are going where based on what the function of these folders are. That's why less is more. Now that platform folder is sitting inside of internal so we can get the compiler protections as well. Nobody can import those outside of the project. And those are like Git. Those are those foundational packages. I didn't want to name the folder Git because that became confusing with some people. So we're naming it platform. And again, you can name these folders anything you want. These are the names that have helped us kind of help to create those mental models. So platform is going to be foundational packages again for this project. They may not be ready to be Git packages. One day maybe they will be. So maybe you're doing some special logging, some special config, some special marshaling. Whatever it is, they'll come under that platform. And then vendor is part of the language tooling now. That's your third party. I'm a big believer in vendoring. I'm a big believer in owning all the source code that you can. Go now has modules. Modules support both vendoring and non-vendoring. If you're not going to use vendoring with modules, then you're going to be relying on a couple of files that you're going to have to keep with this project. And you're going to have to rely on the social contracts that are going along with those third-party packages. I don't want to rely on social contracts to make sure I have a reproducible build. My projects are usually not that big. So I use modules, Go modules, for populating that vendor folder. I will just ask Go modules to also vendor all of the source code and keep everything in one spot. And that's me. I'm always going to be recommending vendoring until it's not reasonable or practical to do so. A project like Kubernetes, pretty big, probably cannot vendor on a project like Kubernetes, but until it's not reasonable, practical to do so, I want you to do that. So your Kit packages, there would become vendored packages in your applications. And we're going to lock those versions in, not just on the social contract with Semver, but also by locking that code in all one place. All right, so we got these 4 folders. We now have a general sense of where things go. That's the whole idea of a project structure, to have a mental model around things. And again, one of those things is, I've got a package. What is its purpose? This is its purpose. Where does it go? And the same decision on Monday is also being made on Wednesday. So we've talked about some of this already, okay, as it relates to location. Vendor is going to be all those third-party packages, including Kit. We're going to use the go space mod command to do that. We do a mod init, we'll do a mod tidy, and then we'll do a mod vendor. Command is going to be where all of the binaries are. We're going to lay a folder in under command for the name of the binary with a main.go under that. We'll see that. Internal is where all that business and service logic is going to be. And then internal platform is going to be where that foundational stuff. So when you come to me and you say, hey, Bill, I have a package I want to build, I'm going to say, hey, what is it? You're going to say, oh, Bill, this package implements a protocol that we need to go talk to some server. It sounds foundational to me. Let's build that under platform. And we can lay things flat. So inside of internal, inside of platform, one of the things I would suggest is lay these packages flat unless there's a real relationship on import dependencies. I wouldn't put folders inside of folders. So definitely leave those packages flat inside of internal, inside of platform, until there's a very clear relationship between, let's say, 2 packages. We'll use the hierarchy for that. Now, again, we're trying to build mental models around package structure. So one of the nice things is the validation, right? We're validating where a package belongs. We're also validating some of the rules around where packages. So here's some like dependency choice validations that we can do, right? We can validate a dependency. So one of the things I love about this project structure is the way I've named it. Because what we're going to say is that imports can happen down that project tree, but not up. In other words, packages inside a command can import anything. Packages inside of internal can only import internal and platform. Packages inside of platform can only import platform and, or let's say also vendor, right? And we look down. So if I'm doing a code review and I see a platform package importing something from directly inside of internal code review stops, hey, that import is going in the wrong direction. That's going to hurt you later on, not help. So we can always be validating these sort of dependency choices and where things are, and that will help smell things out. This isn't easy, by the way. I mean, early on in a project, you're going to fight through this, but as a project matures, it will get better. And policy for me is a really important one. Policy, again, is defining like the dependency choices we've made. What databases are we using? What logger are we using? What configuration are we using? And setting these policies up become really important. So one of the things we'll do, we could do at a high level is say, packages inside of Kit and platform shouldn't be setting policy, because these folder locations are for packages that have to have the highest level of portability, highest levels of reusability. So if you have a package inside of Kit that's importing a logger, guess what? If I don't want to use that logger, I can't use that package either, because that package has set a policy on logging or a policy on config. So we've got to be very, very careful when we're setting policy. And packages inside of Kit and platform, any sort of import outside the standard library should just be double checked. I'm not saying it's wrong. I mean, if it's a database type of package, you're going to be importing a driver. We just want to double check that that policy we're setting is a policy that we're willing to live with, because now it's not as portable or reusable as it otherwise could be. Now, packages in command are at the application level, internals the business level. They can set policy, and they have a lot more flexibility in what they can import as opposed to those other packages. Again, we're looking for the ability to look at a project structure, look at dependency choices, look at policy choices, and validate consistency on every day of the week. Now, we can also validate how data is being accepted and returned from functions. And these are things that we've talked about, right? That consistent use of those data semantics for a given piece of data. Are we using value? Are we using pointer consistency? Are there areas where we're going to go from value to pointer in those small spaces and it's reasonable? Or did we see that we're moving from value to pointer semantics and it wasn't reasonable? We want to catch those. Are we going from pointer to value semantics? We want to catch those immediately because that's just not allowed. It's one of those absolutes that I have. If we're using an interface to accept data, right? Like what's going on? Do we have situations where we can be decoupled, where we can ask for data not based on what it is, but what it does, and we're defining those interfaces, and it's clear and reasonable that we can ask for that, where we need that polymorphism, or we need that decoupling, or maybe we've got interface pollution. We're using interfaces for the sake of using them, and we really should be asking for the concrete data directly, not based on what it is, not on what it does, right? We don't want to, remember, discovering those interfaces. We don't want to get too early into interfaces. When we need them, then let's bring them in. So we can do those types of validations as well. And again, some of the ideas around declaring types when it's something new. All of this stuff is going to be important because when we talk about business level packages like under internal, we definitely don't want to leak dependencies, right? We're going to want to do things like that. Platform packages, again, not leaking dependencies, the policy. So we're going to validate how we're moving data in and out. We can also validate all of our error handling. Whatever project structure you choose, I want you to be able to validate these things as well. Error handling is important because remember what we said about error handling. It means the error has been logged, the error stops here, and our system's back at 100% integrity unless we decide to shut it down. So when you think about those things, right, Kit packages cannot be panicking or shutting down apps. They're foundational. They have no right to shut down an app. They have to return those root cause errors. That would be the same for platform packages, right? You can't shut down. You can't even wrap errors at a platform level because that's setting a policy. Wrapping is not part of the standard library. That's setting a policy. It's a third-party package from Dave. Again, root cause errors. But you know, command is the application. If I saw the command level code wanting to shut down an app, I'd be okay with it. Again, as long as it's reasonable, practical to do so. Internal is business level packages. I still don't want internal panicking or shutting down apps, but they definitely can do that error handling. They can definitely wrap. You see what we're doing here? We're defining guidelines and philosophies, and we're able to leverage this small project structure to say who can do what, who's allowed to do what, and that's going to really help reduce bugs and maintain consistency levels in your code base. So less is more. When I see these project structures that have lots of folders in it, I get concerned because the more folders there is, the more choices, the more inconsistency. It's why I like the idea of command, internal, and platform. We really just have 3 layers, right, in this project structure. And even if we flatten those out, we know exactly where things go and the rules around that. Look, testing as well. You know, at the command level, you could have a package for your tests. Those could be your integration tests at the command level because nothing at the command level really is reusable. But I don't want to see folders or packages inside of other packages that are called tests. We want all of the tests to be bundled into a single package with all that code. And we can validate that very quickly during a code review. Even recovering panics becomes interesting because if a panic is happening, that means there's an integrity issue in the app. Like, not every piece of code has the right to stop a panic. I would normally say that the rule is whatever package owns the Go routine, in other words, the package that constructed the Go routine has the right really to decide whether or not that Go routine panics and shuts down an app. Though it's best if we leave these types of decisions at the application level, at the command level. You might have internal packages that are managing concurrency and multi-threaded primitives, and they probably would be responsible. Okay, and there's lots of other things we can add to these guidelines, and I hope over time you do. But as a team, I think these project structures right here are really great, and they're also a great base to start with your Go project. So focus on, again, having your own kit, if not at a company level, at a team. Think about that as your standard library. And then start to work with this application project. Obviously, make changes, refactor, do things that are going to help with your mental models. Do things that are going to help you validate engineering decisions. Do things that are going to help with consistency. Do things that are going to help in the long term, not the short term. We've always got to think about the idea that this project's going to be successful. We're going to have a lot of people running through it. The data semantic consistency, the project consistency, the decisions we're making at a consistent level where things are located. So they're just so important. So these are my ideas around project structure. I'd love you to start with these. If you see anything new or anything that's working for you, I'd love to hear more about it.